Welcome to The Explainer. Today we're going to talk about a math concept that is, believe it or not, hidden all around you. It's called arithmetic progressions. We'll get into how to spot them, how to use them, and why they're so cool, all by starting with one really simple genius trick.
All right, so we're not going to kick things off with some dry, boring formula. Nope. Instead, let's start with a story. A story about a kid whose brilliant shortcut is the key to this entire concept.
Okay, so imagine you're back in school. The teacher gives you this problem, probably just hoping for an hour of peace and quiet. You'd start, right? 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, and you're already thinking, oh man, this is going to take forever. But there was this one young student, Carl Friedrich Gauss, who saw something different. He saw a pattern. He took the first number, 1, and paired it with the very last number, 100. What do you get? 101. Then he did it again. The second number, 2, paired with the second to last, 99, and boom, 101 again. He realized that every single pair, working from the outside in, added up to 101. Since there are 100 numbers, that makes exactly 50 pairs. So what's 50 times 101? 50, 50. Done. He solved it in seconds. Absolutely brilliant.
Now, this wasn't just some clever little party trick. This simple, elegant idea is the very foundation of arithmetic progressions. Gauss saw the hidden structure under all those numbers, and that's exactly what we're going to do now.
So, what is this pattern that Gauss found? Well, it's a special type of sequence, and really getting a feel for it is, well, it's everything. Think of it like a perfectly built staircase. Every single step is the exact same height. You're always going up, or maybe down, by the same amount each time. Like, say, 10, 15, 20, 25. You can see it, right? You're always just adding 5. That constant little jump is the key. Now, to really work with these things, we all need to be speaking the same language. You've got your starting point, the first term, which we call A1, and you've got that constant jump, the common difference, D. But the most important thing to wrap your head around is the difference between n and a sub n. And here it is, the number one sticking point for almost everyone. Think about it this way. N is the position. It's like your seat number at a concert. Seat number 1, seat number 2, seat 3. It has to be a whole number. An, on the other hand, is the value in that position. It's the actual person sitting in that seat. Getting this distinction right is the secret to avoiding so many common mistakes.
Okay, now that we've got the language down, we can take Gauss's incredible shortcut and turn it into two super powerful formulas. These are your tools. They let you find the sum of any arithmetic progression, no matter how long or complicated it seems.
This first formula, it's literally just the Gauss method written down as math. It says to find the sum, you just take the number of pairs, which is n over 2, and multiply it by what each pair adds up to, the first term plus the last term. It's absolutely perfect when you know where you start, where you end, and how many steps are in between. But what if you don't know the last term? No problem. That's where this second formula comes in. You use this one when you know your starting point, how many terms there are, and that constant step, that common difference, D. So yeah, they might look a little different, but they're really just two sides of the same coin. They're deeply connected. The real skill isn't just memorizing them. It's about looking at a problem, seeing what information you have, and then picking the right tool for the job. So why does any of this matter outside of a math class? Well, because once you start looking for it, you'll see this pattern literally everywhere. I'm talking finance, nature, you name it. Let's check out a few examples. Okay, think about a summer job. Let's say a farmer wants to keep strawberry pickers around for the whole season. So they offer a starting daily wage, but it increases by a fixed amount every single day. If you want to figure out your total earnings after, say, 40 days, that's a classic arithmetic progression problem.
And solving these kinds of real-world problems always follows this simple, brilliant plan. Step 1, figure out what you know. What's your starting point? What's your common difference? How many terms are there? Step 2, choose the right formula based on what you know. Then you just plug in your numbers and solve. It's a reliable game plan that works every single time.
This same logic applies to stuff you can actually see and touch. Take architecture or construction. If you need to calculate how many tiles or bricks you need for a roof or a patio where the rows increase by a set number each time, you guessed it, perfect application. And this is incredibly useful for your own life, especially with personal finance. Let's say you start a savings plan where you put away a little more each month by a fixed amount. You are literally creating an arithmetic progression. And you can use these formulas to see exactly how much you'll have in a year, or 5 years, or even decades from now. Now, to really become a master at this, it's not enough to just know the formulas. You also have to know where the common traps are, and, more importantly, how to sidestep them. So here's a quick rundown of the big ones. Number 1, we've already hammered this home, mixing up the position n with the value a sub n. Number 2 is simple but crucial. N has to be a positive whole number. There's no such thing as the 2.5th term. Number 3 is a great pro tip. Always try writing out the first few terms. It really helps you see the pattern. The rest really just boil down to making sure you're using the right tool for the job, not confusing the formula for the sum of everything with the value of just one single term. And that really is the main takeaway here. Once you genuinely understand that simple underlying pattern, that constant step up or step down, the formulas stop being these abstract rules you have to memorize. They just become intuitive, common sense tools that you can use with total confidence. So, I'll leave you with this question. Just look around your own life. Does your workout routine add 5 pounds to your lift every week? Does the balance on your bus pass go down by the same amount after every trip? Once you know what you're looking for, you might be absolutely amazed at how often you find a hidden arithmetic progression just playing out in the world around you.